Now, recording in progress. So basically, this is actually our third part of actually today's, the same paper. Okay. Now, on your second class. So basically, I would like to actually talk more about these particular questions. Now, I think someone actually to disconnect. So please reconnect while someone to disconnect ito. Okay. So now the structure of the chloroethane. So basically, every questions you actually have to underline or dictate, okay? Make a small notes. That's actually what your I always actually begitu kamo. So E and E, then after that, you're gonna actually have this particular apa itu namanya chloro. Okay, so it is actually a C double bond C that actually have chlorine, okay, attached to them. Now, okay, so what really happened here, you can actually see that this particular structure is actually an ethene. Now remember that previous class we actually talked about there are several actually reactions ethene can actually undergo. One of them is actually formations of your particular polymers. Okay. Now, polymerization is actually one of the reaction that they can actually undergo. What kind of polymerization? Remember, there are two kind of polymerization. One is condensation polymerization, and the other one is actually kamu punya particular addition polymerization. Now, when we talk about addition polymerization, they should actually have C double bond C. So it is actually met the requirement for this particular now. Now, how does actually work? How are we going to actually do the polymer? So it's easy, not like much of condensation polymerization. Condensation polymerization requires two different functional groups. They react together, okay, and they actually remove water. Okay, so that's why we call it condensation. But for addition polymerization, what we need to do is to break the double bond and change the double bond to actually single bond. Now you have to rearrange everything. So in this case, okay, you're gonna actually rearrange in such a way that it would actually be, I'll have to actually draw, but the drawing is not gonna actually be good. Okay, so you're gonna actually have C single bond C instead of double bond. But now, since the double bond actually broken, so you can actually extend the rest. Okay, to actually become a long. So here, yang di atasnya ni is actually always the same balik dengan yang actually yang ni. So it's gonna be H. Okay, H. Okay. Then you have H to bawah, okay, and another one would actually be the Cl. So now this would actually be the repeat unit or the monomer for the polymer yang kamu akan actually buat, which is actually the polychloroethane, okay. Now, polychloroethane is a non-biodegradable, okay? Now, what we mean actually by non-biodegradable, we always actually break it out, okay? Biodegradable, non-biodegradable, okay? The advantages and disadvantages, we learn that actually in class, okay? So what happened for non-biodegradable, they are actually unable to be, decomposed by the act of carbo punya particular decomposers. Now, in biology, we actually learned there are different kind of decomposers. Okay, one of them would actually be fungi, and the other one would actually be bacteria. Okay, so basically that would actually be, tani punya particular decomposers. Okay, or some actually are the small insects, all this kind of thing that's actually considered as the scavengers, decomposers. Okay, now, so for non-biodegradable means that it would unable to be decomposed. Okay, so it will remain the same. Okay, for the rest of entire of the universe, I would just say. Okay, it takes millions of years. Okay, just to decompose small piece of plastic, I would just say. Okay, now, okay, here, okay, that would actually things yang you have to actually understand. Okay, when it comes to actually biodegradable and non-biodegradable. So the consequences of non-biodegradable would actually be littering. Okay, then after that end up in a plastic, so it would actually be able to kill a marine life, okay, aquatic life, okay, because for example, kamu punya particular turtle, okay, sea turtle, okay, they thought that actually the plastic is actually jellyfish because jellyfish is jurang punya particular food, okay, so they tend to actually swallow them without actually knowing. Of course, a human being, okay, would know the difference between plastic and actually jellyfish, okay, so I don't think that, okay, kamu punya particular apa tu namanya turtles, okay, sea turtles, able to differentiate between that two. Okay, so that's the reason why kenapa they end up actually in the alimentary canal of that particular sea turtle, okay, and eventually killing them. Okay, there's a lot, okay, things that actually, and if you burn this, okay, so some people say, why don't we just burn it? Okay, yeah, if we burned it, okay, because all hydrocarbon can actually be burned. Okay, yeah, but when we actually look in terms of the structure, it contains chlorine. Okay, so what actually we are afraid of, they actually produce what we call as toxic fumes. Okay, so that's the reason why we don't actually burn them. Okay, and if we burn them, then it is actually in a controlled environment. Okay, now most of people actually recycle plastics. Okay, um uh, most of them. Okay, and latest technology actually converting able to actually convert the waste plastic into biofuel. Okay, or tadi punya, so because they're made from apa tu namanya, hydrocarbon anyway, so you can actually convert them to actually some other things. Okay, so it actually be able in Japan, okay, they'll be able to actually convert the waste plastic waste into actually fuel. Okay, and but it will take very large amount of money, okay, I would just say investments, okay, to actually just extract a small amount of fuel. So it may actually be one of the technologies in the future, but for not for now. Okay, now let's see. Okay, so let's move on. Okay, I mean, is there any actually questions on this, Nada?
No.
Okay, good. Okay. Now, okay, let's actually clear it off. Okay, and see the next questions. Okay. Now, describe what environmental problem that actually caused by disposal of non-biodegradable plastic. So we all know that, so that we will talk about it. So what are the consequences? Okay, so towards the environment. So that's the reason why we nowadays we actually support using of recycled bags. Okay, or nowadays we actually have biodegradable plastics. Okay, and of course in the tahan macam actually kamu punya plastic biasa, but it's actually biodegradable. Okay, so meaning to say that it actually can decompose. Okay, one of the actually solutions that we can actually come up with. Okay, now draw partial structure of polychloroethene. Okay, show only two repeat units. So you know sudah yung repeat unitnya apa. Okay, so the double bond becomes single bond and long and extended on the sides. Okay, so you just need to add that actually, and it actually mentions that at least two repeat units. So you have to actually talk about, I mean, you have to draw, okay, at least two repeat units. So it's C, then after that you're gonna actually have C, okay, C, and the rest is actually long and extended. So because I just want a two repeat unit, okay, so it's gonna actually be like that. Okay, so hydrogen at the top, okay, hydrogen at the top, okay, so sama, okay, of course hydrogen, chlorine, apa kan to? Okay, chlorine Cl, so you have hydrogen and chlorine. Okay, so at least two repeat unit. Okay, so remember that this would actually, I'm gonna actually just put things in a box so you know that it would be in a repeat unit. Okay, so this is actually considered as one repeat unit. So so you have two repeat units. So basically in terms of that, okay, that how you actually do or show, okay, kamu punya partial structure of the polychloroethane. Okay, so for so good. Okay, now
Yes.
let's clear that off, move on to the next question. Okay, now okay, now for the next questions. Okay, a factory uses 100 ton of chloroethane to make polychloroethane. Okay, deduce the mass of polychloroethane made. Okay, assume that the percentage yield is actually 100%. Explain your answer. And of course, okay, in this case, okay, what happened? Okay, if you use 100 ton, okay, of chloroethane, the amount of actually polychloroethane that actually going to be produced is also the same. Okay, it's 100%. The reason kenapa, you don't actually remove anything, so you don't actually produce any more other product other than actually they're just joining together. So it's just, you know, when you actually have, okay, kamu punya 1 kilo of paper, okay, and you put in the, you know, a plastic or something like that, it would still be, okay, I mean, you bind it into one book, okay, it's gonna still be 100 pages, okay, so 100 or 100 kilos, okay. So basically in terms of that, okay, if you use, or if you actually use 100 kilo or 100 tons of chloroethane, okay, you will also produce gonna be, you're also gonna actually produce 100 tons of polychloroethane, because you just need to adapt the small molecules to become but bigger molecule, macromolecule. Come on. Now, chloroethane react with hydrogen in the presence of actually a catalyst. Okay, so chloroethane. So we don't talk about polychloroethane. So artinya the chloroethane still actually have to C double bond C. Now react with hydrogen in the presence of the catalyst. Okay, so basically in terms of this is actually a process of addition. Okay, we're gonna actually you know, okay, take that. So basically react, okay, with hydrogen. Okay, so salah. Okay, I should actually do the box. I don't know why they keep on changing this. Okay, the hydrogen, okay, present of catalyst. Okay, so basically in terms of that chloroethane. So artinya you're gonna actually have that the double bond thing. Okay, so you're gonna actually have C double bond C, okay, double bond, okay, C, okay, so you have H and H, okay, uh, hence not stable. Okay, so your connection not stable. Ani, hand is not stable. Sorry. Okay, so what happened is that you can actually break that particular. Now reactions with actually hydrogen. So remember, okay, for all the ethane, okay, they undergoes addition reactions. Okay, so hydrogen is actually been added. Okay, another name for this particular reaction is what we call the halogenation. Sorry, okay, hydrogenation, not halogenation. Okay, halogenation is actually when you add halogen into the structure of the ethene, okay, but you don't add it. Oh god, okay, look at that, sasalah, okay, okay, it's supposed to be Cl, okay, one of them, okay, so it would actually be this one, okay, so it should be Cl, okay, so Cl, okay, so now here, okay, with the hydrogen, okay, with the hydrogen actually been added, okay, so the double bond would actually breaks, okay, and the double bond, once you actually broke the double bond, so you can actually add, okay, two actually of hydrogen molecules, because we only have hydrogen anyway, okay, so we can actually add hydrogen on each of the carbon. So remember, the carbon can actually have 4, okay, different atoms attached to it, okay, so it's fully, okay, so basically the double bond only considered as 1, so basically this still can actually add. So this is actually the reason kenapa juga kena panggil, we actually panggil tani punya particular alkene tani ini is actually unsaturated hydrocarbon, because we able to actually add things up, okay, it's not fully occupied yet. So for this would actually change it into actually kamu punya halogenal alkane, okay. Now the structure that would actually become would be like this, okay, so it would be C single bond C, because the double bond broke, okay, so you will actually have same, masih ada hydrogen yang tadi, ini hydrogen yang bermula, okay, so okay, then after that you have the chlorine tadi, okay, and the hydrogen yang mula-mula. Now you have to actually add hydrogen, actually kamu punya hydrogen di sini, each of this particular carbon, okay, so that would actually form, okay, this is actually what we call as kamu punya particular, okay, halogenoalkane, okay, we call this as halogenoalkane. So halogenoalkane, okay. Now why we call it halogenoalkane, because we actually have this particular, okay, apa tu namanya, this particular halogen attached to the structure of an alkene, okay, so structure of an alkene would actually be this one, okay, C single bond C, okay? So that's the reason kenapa kita panggil halogen alkene. So remember, for the double bond, okay, you have to identify what are the reagents that actually they used, okay? And, okay, what the reagent can actually split into. So basically, kalau yung chloroethane, okay, react with steam, okay, or water, you still can actually make, okay, instead of actually kamu punya particular, apa tu namanya, instead of the HH, you can actually convert that to actually H and OH if it's actually with steam, okay? And if it's actually added with Cl2 ataupun Br2, then you can actually just change this both HN into BR ataupun CL ataupun HBr, okay? Kalau they use HBr, then you use H sini, BR sebelahnya, okay? All that kind of thing. So these are the things that actually, as I said, it's predictable. In chemistry, the organic reactions are predictable. So you just need to know what are the reactant, okay? And you'll be able to actually predict the products, okay, eventually. Now, is there any questions? So sila to, okay, Mr. Araujong ka, okay? In terms of this, okay,
No.
yeah, it doesn't mean that it doesn't mean actually that there's actually kita ni punya CL atau diujong, okay? Ia boleh di bawah sini and everything, tapi jangan diubah. So basically in terms of this position niya ni, because actually there's only 2 carbon di sini. Let's say that actually you have 3 carbon, okay? And the carbon actually the CL atau attached to actually the 3rd carbon, for example, like this, okay? So I'm gonna actually give you an example. So if you actually have C, okay? C, okay, then double bond, okay, C, okay, then the chlorine is here, Cl, then di sini is H, and then after that actually H, okay, then after that you're gonna actually have, okay, another 3H di sini. So now, in this particular case, if you actually react this particular alkene with H2, okay, so you're still gonna actually have a H2, okay, so they will actually be able to actually form, okay, so C, panjang juga, okay, so C, okay, so H masih sama, H, okay, masih sama, H masih sama. Now, okay, you're gonna actually have C, okay. Now, instead of actually double bond, now actually I broke it into actually become a single bond, okay. Now, okay, since I actually add that, so the chlorine should actually stays actually arah dia punya particular tempat originalnya. So I just add hydrogen sini, okay. Then also hydrogen di sini, okay. Addition to actually the previous hydrogen from this side, okay. So the one yang you add is actually, I'm gonna actually use a box, okay. The one you're gonna actually add is this one, okay. So that was actually the one yang actually come from Ani, okay. So for so good. Okay, now, okay, so let's say, okay, now, so what will actually happen if I use, okay, H2O, sama, okay, so in terms of this, okay, when it comes to actually sama macam, let's say, I'm gonna actually change this to H2O, okay, so I have, kenapa tu ya, okay, text saya salah, draw, okay, so H2O, okay. So if we actually have H2O, so remember that the H2O will actually split to become H plus, okay, and OH minus, okay. So these are the one actually kamu will replace yang H di sini ini jadi O and also OH. So it's good. Okay, so you replace saja kamu punya particle. So that's the reason kenapa kita dipanggil ya addition reaction. So let's say another one. So what if I actually use HBr? Again, it's going to be the same. Okay, I'm going to actually put H, okay, B, R. So the HBr will actually form, okay, H plus and Br minus. Plus, okay, Br minus. Okay, so here sama juga. Okay, replace that actually H, ini kamu punya H dengan H1 di sini and BR di sini. Okay, now so okay, is the positions actually matter? The reason actually for this level it doesn't matter. Okay, you will still get the right answer anyway. Both, okay, you can put the BR on the H side or the H side on the BR side. Okay, we actually have both actually exist as a product, but in next level, in A level nanti or S level, then you will actually know that there's actually what we call a minor product and major product. So it depends on the stability of the structure, okay, where there's actually the positions of the BR. But both particular products actually exist in real world. So that's the reason why at this level, if you put the BR arah H arah BR to still actually give you the correct answer anyway, okay? So that would actually things yang you have to remember. Now, okay, what if I actually use BR2, okay? Sama, okay, we actually use the halogen saja. We're gonna actually try to use a different color. So we're gonna actually use a green color. So we're gonna actually have use BR2, okay? Apa tu? Okay. So BR, okay, 2, okay? So basically, okay, B juga. 2-nya ni, okay? Mana sini? Okay, so BR2. So the BR2 will actually have, okay, kamu punya particular 2 BR. So sama dengan H2, okay? So you can actually put BR1 sini and BR1 sini. Now, do you realize that I actually only add this particular area? Okay, I'm gonna actually just circle that. I mean, not circle, put it actually in the box. Okay, I only actually put within this area. Okay, I don't change. Okay, the reason kenapa? Look at this. Okay, the double bond actually only exists that area, so you can actually only add within that area sahaja or the 2 carbon itu. The rest of the actually no, I don't touch the CH3 yang ani. Okay. So I'm not gonna actually touch here. I'm not gonna touch here. Okay. So the reason, okay, is because, okay, as I said, that is not actually the functional group, the one that actually yang reacting. The functional group that reacting now is actually the alkene. So far so good. Any question?
No.
Good. Okay. Good. Now, okay, good. Okay. Ifa, okay, Ifa.
Okay.
Okay, that's good. Okay, now let's just move on. I'm gonna screenshot this, or you're gonna wanna actually copy it. It's up to you. Okay, and we're gonna actually move on to the next one. Okay, now let me clear all my drawings dulu. Okay, so let's move on. Okay. Ta-da! Okay, now next. Okay, ngalih membuat meng-clear by one click saja. Okay, so again, let's see next questions. Okay, now you have copper to chloride, copper to iodide, and copper to carbonate are ionic compound. Now, so you need to identify them, okay, as in, okay, look at here, okay. Now, what we're gonna actually look at, we're gonna actually look in terms of copper iodide, okay. The cation remains the same, but the carbonate ions are actually changing. So you actually have Cu, okay, CuCl2, okay. So Cu, okay, I2, okay. Then after that, CuCO3. Okay, so that what actually things yang you have to remember. So you're gonna actually have here. Okay, copper. Okay, maybe the color nito. Okay, let me change the color. Okay, so one. Okay, just this color. Cu. Okay, Cl. L2. Okay. This one is copper to iodide, so Cui2, okay. Here copper carbonate, okay. So copper carbonate is CuCO3, okay. CuCO3. Okay, kenapa Cu2 plus CO3 2 minus? So cancel off, so becomes CuCO3. So CuCl2 kenapa? Because Cu2 plus and Cl minus. So you actually exchange your particular no. So sama jua Cu plus, okay, Cu2 plus, sorry, okay, and I minus, so you will actually form Cui2, okay. Predict two physical properties other than electrical conductivity of copper to chloride, okay. So of course, okay, all chlorides are soluble in water, okay. So you can actually say that, okay, they're gonna actually form, okay. What's the color of the solution? That would actually be blue, okay. So far so good, okay. So it would actually be soluble in water, okay, insoluble in organic solvent, okay. So there's actually things yang you have to remember sana, okay. They have high melting point and boiling point juga. So that is actually characteristic of kamu punya ionic compound. So ionic compound actually have high MPBTs, okay. At the same time, that can actually be whether it's the solubility depends on what kind of actually anions are there, okay. Kalau chloride, all chlorides actually are soluble, okay. So basically in terms of this, okay, they will form a blue, kamu punya blue solution, okay. Now, most of kamu punya particular ionic compounds are solid. So begitu sudah kan previously. So most of actually ionic compounds are actually solid. Okay. Kalau nada water is actually added, then there would actually be state-nya would actually be solid itself. Tapi kalau nya actually ada water or ada aqueous solution is been added or reacted, then it depends on the reaction. Is there any precipitation actually occur ataupun tidak? How do we know precipitation occur? Look at dia punya particular, okay, saltnya to. Is the salt actually sulfate ka, okay, company chloride ka, ataupun nitrate ka? And ask yourself whether that salt is soluble ataupun tidak. Kalau soluble, then after the reaction, when they form the product, then it will become aqueous. Kalau insoluble, then they will actually become, okay, precipitate, okay. That's how you do the qualitative analysis anyway, okay. So far so good. Any question? Now, okay, so really important, okay, for us to actually understand the ionic equation, ionic compound. Now, copper is a transition metal, okay. Now, suggest one property of copper to chloride that is actually characteristic of a compound of colored transition element. So it will produce a colored compound, okay. So basically, it would actually be able to produce colored compounds. So first of all, okay, and of course, variable transitions. There's actually it's a property of color that is characteristic compound in transition metal. Yeah, okay. So basically that would things yang more compound. So basically it actually form a colored compound. Okay. Now copper react with the chlorine to make copper to chloride. Okay. So you'll be able to see here. You will be able to see. Okay. I'm gonna actually clear that. Okay. Drawing the law, okay. So copper to react with chlorine to make copper to chloride. Okay, so the copper to chloride contains Cu2 plus ion and ion minus ion. Explain in terms of the movement of electrons, our Cl2 formed, okay, in the copper atoms and chlorine molecules. Now, you have to actually understand this. I want you to actually just, okay, make a box for that, okay. So then, okay, what you're gonna actually do, you're gonna actually have this. So this is actually an ion, okay, anion, okay. So anion actually apa, okay, receive, okay, or take in electron, okay. So cation on the other hand, okay, would actually able to give off, okay. So they'll be able to actually give off your particular, okay, apa itu namanya, okay, electron. So give off, sorry, okay, give off electron, okay. So they can actually give off electrons, okay. So again, okay, the reason kenapa you actually form this, okay, I'm gonna actually have that, okay, from here, okay, to here, okay, from here, okay, this to this sini, because, okay, one chlorine atom can only receive, or chlorine ion, sorry, one chlorine ion, okay, be able to receive satu electron sahaja. However, when you look at Cu2 plus, they can give two electron, okay. So basically two electrons, okay, by the copper ions. So basically to form a copper ions, the copper need to release two electrons, okay. So to form an ion, okay, Cl minus ion, okay, they will have to accept one electron sahaja. So chlorine able to accept one. So that is the reason kenapa kamu require two particular, you require, okay, here, okay, you require two chlorine to accept two electrons from the copper. Okay, so far so good.
Yes.
Okay, good. Okay, so remember, Ani Juni, okay, we have to remember, okay, apart from itu, you have to actually remember pasal concentration juga. So kalau you actually talk about the concentration, okay, and they ask you to find the concentrations of actually chlorine, okay, atom, okay, in the copper chloride. So let's say I have about 0.1 mole per dm cube here, 0.1 mole, okay, per dm cube, okay, of copper 2 sulfate, okay, as copper 2 chloride, okay. So basically what happened, I will have 0.1 mole, okay, dm cube of Cu, and you actually have 0.1 mole per dm cube of chlorine. Okay, 0.2, sorry, okay, the reason kenapa 0.2, okay, so okay, from here, okay, I'm gonna actually draw, okay, sorry, okay, I cannot confuse kamu, okay, so I actually have copper, okay, in the copper, okay, here is 0.1 mole, okay, per dm cube, okay, -3, okay, so I forgot to actually put -3 di sana, okay. Okay, whatever, okay, I'm gonna select that, okay, -3, okay. So for dm cube, now here kalau kamu punya actually talk about the chlorine, okay, so the chlorine would actually be having 0.2 mole per dm cube. Okay, now kenapa ya actually cuma tu? Because of you punya mole ratio. You look at that, how many chlorines are there? Twice. So basically, if you have 0.1 mole of copper, you will require 0.2 mole of actual chlorine to accept that 2 mole of kamu punya 0.1 mole, okay, of I mean 0.1 0.2 mole of electrons, okay. So basically, kenapa one kamu punya copper can give you 2 electrons. So in this case, you will require twice, okay, the concentrations of the copper in order for them to accept all of the electron kamu. So kalau kamu use or do a calculation, okay, and they ask you about kamu punya particular this apa tu namanya, concentration of each of that particular atoms, okay, you will actually have to look at the initial concentrations of the solution dulu. So the initial concentration of solution will actually tells you what would the apa tu namanya, concentrations of each. So since actually 0.1 mole is the concentration of the solution, so the mole ratio of copper is 1. So it is always the same as kamu punya particular the solution. But now chlorine actually have twice, 2, okay? So in this case, okay, you're gonna actually have double concentration, concentrations of Cl, okay, dalam solution na to. So for so good.
Yes.
Yes, okay, good. Okay, now let's actually see. Okay, now in terms of the next one, okay, because I have to actually able to, you know, able to explain to kamu not only just based on the questions, but the things that I actually can think of, okay, that may actually be related to that particular question, huh? Now let's actually clear that off, okay. Now sudah kamu ano screenshot whatsoever, okay. So basically screenshot it or copy that before we move on to the next one, okay. So we actually have about 4 minutes, okay, apparently, okay, left, okay. So now let's see, okay, in terms of the next question. So now, okay, copper to iodide decomposes to make iodine and copper 1 iodide. Okay, so the ionic equations for this reaction is actually shown. Okay, use the explanation in terms of oxidation takes place. Now, in terms of this, okay, oxidation. So I always beritahu kamu kan, if we actually talk about oxidation, okay, so how to actually prove that there's an oxidation? We actually use sama ada oxygen gain, okay? Then kamu punya removal of electrons, removal of hydrogen, or okay, increase in oxidation state, okay? Now, do you see any electron actually been shown? Okay, we can't see that, okay? Do you see any hydrogen is actually been shown there? We can't see that, okay? Do we see any oxygen involved? And we can't see that. So the only thing that you can actually mention here is the oxidation state. Now, okay, so basically, I can explain the oxidation state, okay? So what actually, oxidation, okay? Oxidation is gaining in terms of oxidation state. So, you punya particular oxidation state increase. So, okay, I'm gonna actually look in terms of this, okay? So, Cu, okay, 2 plus, you start with the Cu2 plus di sini, okay? Now, the Cu here, I'm gonna actually drag that, okay? Here, okay? So, it would actually be, this is actually Cu, okay? Cu plus, okay? And okay, here is I minus, okay? I minus, okay? Okay, so I minus, okay? So what will happen is that, okay, you start with Cu2 plus, okay, then you become Cu. So is it increasing or decreasing? The answer is decreasing. So it's not actually the oxidation, it's the reduction. So, okay, automatically, okay, automatically, okay, so kamu punya particular iodine or the iodide is actually been oxidized, okay? So now how do I see that? So you're gonna actually be able to see, okay? Kamu punya particular iodide, okay? Here, okay? You start with 1 minus, now you become 0, okay? I'm gonna actually put an arrow from here to here, okay? You start with actually -1, okay? -1, okay, and you end up, oh, sorry, to overlap, okay, let's see, okay, so -1 and now actually become 0, okay, so that would actually become 0, okay? So you have to remember that, okay? When it comes to Campiano. Now, so kenapa I2 is 0? It's a compound. So compound is always actually 0. So sum of oxidation state in a compound always equal to 0. Remember that. So if you want to find, okay, oxidation state of certain particular, apa tu namanya, certain particular ions, okay, or element or atom dalam actually compound na to. So you have to actually plus everything together equal to 0. So that's actually one of the things that you have to remember. So now, okay, use the information to explain the oxidation takes place. So oxidation, so kamu punya iodide is been oxidized, okay, from -1 to actually become I2 with actually 0 oxidation state. Yeah, okay. So far so good. Now, use the information to explain that reduction takes place. So reduction sama, okay? So when we actually talk about reduction kamu, okay, we would actually definitely gonna actually be talking about, okay, your particular, okay, copper. So copper has been reduced. Why it's reduced? Because you start with actually Cu2 plus. Now actually becomes Cu plus sahaja. So from 2, it becomes 1. So it reduction in terms of oxidation state. So basically that